Okay, so if you're going to fill out a unit circle, there are some things that you need to know. First of all, you need to know the special right angles, or the special right triangles and the special angles, which are 45, 45, and 90, and 60, 30, 90, where the ratios are provided. But you need to know that. And you need to know that in the unit circle, so unit circle is called a unit circle because it has a radius of 1. And because it's a unit, because the radius is 1, if you take any angle on there, like theta, the coordinate value that corresponds to theta, the coordinate value xy, creates like this little reference triangle in here, and I'll draw that a little bigger, where I have a right angle, I've got my angle theta, and I have xy, which means that I'm moving over x and up y, but the hypotenuse is 1. So what's cool about a unit circle is that I know that sine of theta is y over 1. In other words, sine of theta is y. And I know that cosine of theta is x over 1. In other words, I know that x is cosine of theta. If you know these things and you know that the unit circle is made, the unit circle angles are multiples of special angles, you can do this entirely by hand. So the first thing I would do with the unit circle is I'd start filling in some of the angles. So I know this is 0. It's also 360 because that's a full revolution. This angle here is a 30-degree angle. That one here is 45, that one's 60, and that one's 90. And then the rest are just multiples of those. This here is a 30-degree angle, so I'm adding 30 to 90, so that's 120. This here is 45 from here, and 45 plus 90 is 135. You can also notice that the difference between these is 15 degrees, so I can just add 15 degrees, and that's 150. Or you can say, well, I've got 120, and I'm adding another 30, so that's 150. And then over here, I have 180 degrees. You can continue doing that for all the other angles. It's a little bit more complex with the radians. If you want, you can convert the degree measurements to radians. I like to look at it in terms of, well, I know I've got 0 radians here, I've got a full revolution is 2 pi radians there, and then I just try to remember that 30 degrees is pi over 6 radians, 45 is pi over 4, and 60 is pi over 3, and 90 is pi over 2. And then I do everything else by multiples. So I know this is pi over 3, which is 2 pi over 6s. Well, this is also 2 pi over 6s, so that's 2 pi over 3. I could find all the 45-degree angles, or the pi over 4 angles, because that's 1 pi over 4, 2 pi over 4, which simplifies to pi over 2, and that's 3 pi over 4, and so on and so forth. And that's how I go about labeling all the angles of the unit circle. I'm not going to finish it. I recommend that you try to finish that by hand, and then you can check your work by just looking it up on Google. We can label the coordinate values of the unit circle just by realizing that we're on an xy coordinate axis, and because this is a unit circle, the radius is 1, which means that this coordinate here, I'm moving all the way over 1, but I'm not going up or down any, so that's just 1, 0. Here, I'm starting at 0, but I'm going up 1. Here, I'm going back. My x-coordinate is back 1, but I'm not going up or down. And here, I'm not moving to the left or right, but I am going down 1. So those are called the quadrantal angles, and we can find the corresponding coordinate values on there. And then the others, I use the special right triangles. I know, again, recall over here, that sine of theta is the y-coordinate on the unit circle, and x is cosine of theta. So over here, the y value is just sine of 30 degrees. Well, if I don't want to go back to the other one, so I'm just going to do it again here. So sine of 30 degrees is opposite over hypotenuse, which is 1/2. This value here is cosine of 30 degrees, which is root 3 over 2. I can do the same thing with this coordinate value here. The y value is sine of 60 degrees. Well, sine of 60 degrees is opposite over hypotenuse, which is root 3 over 2. And cosine is adjacent over hypotenuse, which is 1/2. And then I've got my 45-degree angle over here. So I'm going to redraw the special right triangle with 45 degrees. Again, this is just half a square. And if the side length is 1, I can use the Pythagorean theorem to find that the hypotenuse is root 2. So what's sine of 45 degrees? Well, it's 1 over root 2. What's cosine? It's also 1 over root 2. And yeah, that might be well and good for these, but then how do you actually go about solving these values? Well, notice these are all just symmetrical to these values. So like this coordinate is the same exact coordinate here, except instead of going over 1/2, we're going back 1/2, but we're still going up root 3 over 2. Similarly, for this coordinate, it's just a reflection of this coordinate about the y-axis. So these are also each 1 over root 2. However, the x-coordinate is also negative. Okay. I'm going to stop there to let you finish that up. Yeah, that's a great question, Isaac. So the question is, do you just watch for what quadrant it is to see whether it's positive or negative? Absolutely. So I don't actually really pay attention to the quadrant. It's not like I think, oh, I'm in the third quadrant here. So where's it negative or positive in the third quadrant? I just kind of think of it as a coordinate axis. And I say, well, if I'm going to the third quadrant, I'm going back a certain number and down a certain number. So like, you know, that might be -3, -4 or whatever. And I just know, okay, so cosine and sine are both negative in that quadrant.